Hi, scholars. Happy Tuesday. Today is Tuesday, May 12th. Today, we're going to continue working on dividing fractions. Tomorrow, you will have a quiz on both multiplying and dividing fractions, and you'll have your final spiral review assigned, which is mostly on multiplying and dividing fractions. Then we'll start our final unit of fifth grade, our final review unit. And next Wednesday, you will take your final assessment that covers everything you have learned throughout the course of fifth grade to make sure you are prepared for sixth grade. So not a ton of time left. Let's make sure we stay really focused and crush this division of fractions. I want to start with some shout outs from yesterday. These are scholars who were in the 80 to 100% club. Yesterday, you had both multiplying and dividing fractions. Scholars with the asterisks by their name scored 100%. And everyone else scored between 80 and 100. So huge shout outs in UNC to Dillery, Emmanuel, Tembi, Anaya, and Jaden. In SCU, quite the long list: Naira, Ricardo, Abimael, Philip, Amelia, Jakira, Alejandro, Corday, and Adam. And Duke, kind of a sad list for you. Just one scholar, so huge shout out to Larry. Really nice work to scholars on this list. Cannot wait to continue seeing more and more names. Should see a lot more names tomorrow on tomorrow's list after we get some more practice dividing fractions today. Now, yesterday I did mention that we were really focused on drawing models to represent all of our problems. Today, we can always continue to draw models, but today we're also going to talk a little bit about the standard algorithm for dividing fractions. Some of you, I noticed in office hours yesterday, were already starting to notice what that standard algorithm might be. So I'm excited to talk a little bit today about how we can actually solve these without drawing a model. We're going to start by actually looking at a problem that we looked at yesterday. So yesterday, we read the story about Dr. Zamora. Dr. Zamora, for Teacher Appreciation Week, had bought 8 cakes and she was going to send them out to the teachers. But as you remember from yesterday, Dr. Zamora knows that a teacher does not need to eat an entire cake by herself. And so she was actually going to cut her cakes into fourths so that every serving or every piece would be 1/4 of a cake. And she wanted to figure out how many servings she had. And if you remember from yesterday, we were really focused on models. We drew out the 8 cakes that Dr. Zamora had ordered. I always use squares because they're just easier for me to split into fractions. And then she was not sending a whole cake to a teacher. Instead, she was cutting those cakes into fourths so that everyone could have 1/4. And she wanted to figure out, well, if I have 8 cakes and I'm dividing them into pieces that are 1/4, how many pieces do I have? And yesterday we counted. We said, well, it would be like if I got this piece right here, Mrs. Dunn got this piece right here, Miss Richardson got this piece right here, Miss Trotter got this piece right here. How many teachers can we actually serve? And yesterday we counted them all up and we said we got to an answer of 32. And I was noticing, as I was working with some scholars during office hours, scholars who were saying, well, I don't want to count all of those by ones. In fact, I can count by 4s, and I don't even have to count by 4s. I don't have to say 4, 8, 12, 16, and go on and on and on. I actually know that if every cake has 4 pieces, I can just do 8 times 4. And that will get me to my answer of 32. So some of us were already starting to see this pattern yesterday that 8 divided by 1/4 is exactly the same as 8 times 4. Really interesting. Okay, keep that in mind. Let's take a look at one more. See if you can start to figure out, well, how could we how could we divide these fractions without even having to draw a model? So yesterday we also looked at the story about Corday. We know Corday, our big pizza winner, a couple of weeks ago. Now he only had a fourth of his pizza left. He'd eaten the rest. And then he wanted to eat that leftover pizza, the leftover 1/4 pizza, over the next 2 days. And we were trying to figure out how much pizza he should eat each day. So yesterday when we drew a model, we drew the 1/4 of a pizza that Corday had left. Some of us even put some X's right here, thinking, well, he's already eaten that pizza. I just want to focus on this 1/4 of the pizza that he has left. And he wants to eat this evenly over 2 days. So we need to split this. And we said, well, he could eat a little bit Monday and then a little bit on Tuesday. And so we were trying to figure out, well, if Corday has 1/4 of a pizza and he's dividing it by 2, how much pizza or what fraction of the whole pizza can he eat each day? And we knew we couldn't just say our answer was 1/2 because this is not half of the whole pizza. It's a half of the fourth of the pizza that he had. And in fact, even when we start talking about it like 1/2 of 1/4, it makes me think of multiplication. And so even though this is a division problem, we can think of this as he has a fourth of the pizza, but we want to know if he's just going to eat half of the fourth, what fraction of the whole pizza is that? And yesterday, using our model, some of us drew in some of these dotted lines so we could count all of the pieces, and we realized, well, in the entire pizza, there would be 1, 2, 3, 4, 5, 6, 7, 8 pieces. And so Corday can eat 1/8 of a piece on Monday and 1/8 of a piece on Tuesday, and he'll have eaten, then he'll be done with his whole pizza. So as we look at these sets of equations and we start to think about, okay, when we divide by a fraction, I'm noticing it's actually the same as multiplying by the inverse of the fraction. And we know that when we say inverse, we just mean the fraction flipped. And so, for example, we know that like the inverse of 1/4 becomes 4/1, right? We just flipped it. The numerator became the denominator became the numerator, which we know is the same as 4. We literally just switch the numerator and the denominator to get the inverse. Let's try another inverse. Let's say I wanted to find the inverse of 2/3. Well, to find the inverse, I'm just going to switch my numerator and my denominator, and the inverse would become 3/2 or 1/2. Okay, you try one now. We're just going to solve the inverse. I want you to find the inverse of 1/5. When we say inverse, we're just switching the numerator and the denominator. It's like flipping the fraction upside down on its head, flipping it over. And you should have gotten 5/1, but we know that's just the same as 5. We don't ever write our fractions with the denominator of 1 because we know that just means it's a whole number. Okay, let's try one that's a little trickier. What is the inverse of 3? How do we invert that? Well, we have to remember that this fraction 3, or this whole number 3, excuse me, is actually 3/1. So when we find the inverse of it, excellent. It's just 1/3 is the inverse. So we're going to get some more practice with inverting fractions, finding the inverse, finding what it is when you flip it over, flip it on its head. But as we look at what we just proved with our models, I'm noticing that 8 divided by 1/4, it's the same, I get the same answer as when I did 8 times the inverse of 1/4, which is just 4. I just flipped that 1/4 over, which would make it 4 over 1. We don't really need to write the 4 over 1. Just gonna write a little dots right there. But if it helps you to visualize how we inverted the fraction or flipped it over, you could write that in. And then interestingly, when we had 1/4 divided by 2, we figured out that was 1/8. We got the exact same thing as when we did 1/4. So the same fraction, we kept the fraction, we changed division into multiplication, and then we took the inverse of 2. Now I know 2 is actually 2 over 1, so it's like we just flipped it to be 1/2, but then that way I can actually multiply. Pretty cool. Let's try one more and see if this works, and then we're actually going to learn the rule for how this works. We're starting to understand why it works. Let's try one more. Let's see if we can apply this idea to, let's just say I have 3 pans of brownies, and I'm going to split each of them into fifths. And I want to know how many pieces I have. Let's try it without drawing a model. We'll go back and prove it with the model, but let's see if what we were doing up here works and I can solve without actually finding a model. So notice that I didn't do anything to my first number. My 8 stayed the same. My 1/4 stayed the same. So I'm not going to change anything about the 3. I'm just going to keep the 3 the way it is. Let's try changing our division into multiplication and then finding the inverse of 1/5. The inverse of 1/5, I just take 1/5 and I literally flip it on its head. So if I need to write it down in the side, I can. I'm going to flip it over so the 5 goes up and the 1 goes down, which gives me 5 over 1. I know it's the inverse when I've literally moved the denominator to the numerator and the numerator to the denominator. But once I have 5 over 1, we know that that's equivalent to 5. So this would be the same as 3 times 5, which gives us an answer of 15. That I can do nice and easy in my head. So let's see if when we draw the model, we get the same answer. So I said 3 pans of brownies. There they are, always drawing what we start with. And I'm dividing them into pieces that are the size of 1/5. So in each pan of brownies, 1, 2, 3, 4, 5, 2, 3, 4, 5, 1, 2. All right, so I've split them. So each piece is 1/5 of the whole pan, and I want to know how many pieces I have altogether. Well, I can already see, oh yeah, I could count by 1s, but I could also count by 5s 3 times, which is the same as 3 times 5, 5, 10, 15. And we do, in fact, get the same answer. So it really does work. I really can divide by a fraction by keeping my first number the same, whether it's a whole number or a fraction, changing my division symbol into multiplication, and then flipping my fraction or whole number into the inverse, and I get the same thing. Pretty cool. But we can see why, because if I have 3 pans of brownies and I'm splitting them into pieces that are a fifth, that means each pan will have 5 pieces. And so I need to multiply by 5 to figure out how many pieces there are, which is the same as 3 times 5. Or if we're starting with a fraction, moving back to Corday's pizza, notice I didn't take the inverse of my first fraction. My first number always stays the same. I just want to keep that the same. But dividing by 2 is actually the same as multiplying by 1/2 to get me to our final answer. Pretty cool stuff. Let's take a look at how we can remember this. So when we are dividing a fraction, dividing by a fraction, you are always, 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 always welcome to draw a model. If you are at all confused or you're thinking, I don't understand why I'm doing this or this doesn't make sense, draw it out. We had huge success yesterday with scholars who were drawing out their models, splitting them into the right number of pieces to divide by a fraction. But if you're starting to recognize the pattern, a slightly faster way of doing it and remembering it is this idea of keep, change, flip. We say keep, change, flip. We say keep, change, flip. Say it with me. Get ready, go. Keep, change, flip. Again, keep, change, flip. One more time. Keep, change, flip. Okay, let's talk about what this means. When we keep, we're just keeping the first number. Now, this could be a whole number or a fraction. We keep it exactly the same. This is the easiest thing anyone could ever ask you to do because you just don't touch it. Rewrite it exactly the way it is. So we keep that first number. This is true whether it's a whole number or whether it's a fraction. And we'll take a look at some examples. So we keep that first number the same. We keep our first number the same. After keep, we change. Remember, it goes keep, change, flip. Keep, change, flip. So after we keep the first number exactly the same, we just change the symbol. We're changing division to multiplication. We're changing division to multiplication. We are changing the division symbol to multiplication. This is great news because we are experts at multiplying. So first we keep, then we change. First we keep, then we change. Keep that first number exactly the same, then we change the symbol. The last part is probably the trickiest part, even though it's still not even that tricky. And the last part is to flip. The last part is to flip. The last part is to flip. And this is where we are literally flipping our fraction over, flipping it on its head. So we flip that second number. Now, it could be a whole number or it could be a fraction to be the inverse. We know the inverse is just a number inverted or flipped over so that what was the denominator is now the numerator. What was the numerator is now the denominator. So the last thing we do is we flip. The last thing we do is we flip. The last thing we do is we flip. So to remember how to divide by a fraction, we can just remember we're going to keep, change, flip. We're going to keep, change, flip. Let's take a look at some examples. Let's say I'm starting with 4 wholes. This could be like my 4 pizzas. And I'm going to divide it into sixths, into 1/6. And so again, if I want to think about it like pizzas, it's like I have my 4 pizzas and I'm cutting each one into pieces that are the size of 1/6. And I want to know how many pieces do I have. Well, we could draw out our model and draw our 4 pizzas and cut each one into sixths and then count up all the pieces with 6 pieces in each pizza. But if we didn't want to have to draw a model, we could use our keep, change, flip. Let's take a look. Keep. We keep the first number exactly the same. It doesn't matter if it's a fraction or a whole number, I keep it the same. So nothing changed between my 4 and my 4. I kept it the same. The next thing we do is we change. The next thing we do is we change. So I changed my division symbol into a multiplication symbol. And then the last thing I do is I flip. The last thing I do is I flip. So I'm going to flip the second number, whether it's a whole number or a fraction, I'm going to flip it to be the inverse. Now in this first example, I started with 1/6. When I flip 1/6 over, it gives me 6/1, but I know that's just the same as 6. And so when I multiply by the inverse, 4 times 6, I get an answer of 24. This makes sense. I understand why, because if I have 4 pizzas and I cut each one into sixths, that means each pizza would have 6 pieces. And I want to know how many pieces of pizza I have. So I would count 6, 12, 18, 24, which is the same as doing 4 times 6, which gives me that answer of 24. Let's take a look at another example. Here in example 2, we're starting with a fraction. All right, don't get tricked. I don't just automatically flip every fraction. I only flip my second number. So my very first step is to keep. Remember, we keep, change, flip. We keep, change, flip. We keep, change, flip. And so my very first number, 1/5, this would be a story like, oh, I only have 1/5 of a pizza left, but I have to share it with 3 people. What fraction of pizza will each person get? I know it's going to be smaller than 1/5 because I only have 1/5 and I'm splitting that into 3 pieces. Another way of thinking about that is I'm taking 1/3 of 1/5. And we know that of signals its multiplication. But let's take a look using keep, change, flip. So I'm going to keep my first number the same, so I don't touch my 1/5. It stays exactly the same. Then I change my division into multiplication, and then I flip my second number, which is a 3. So even though it's a whole number, I still have to flip it over and get that inverse. I know 3 is the same as 3/1. If I flip that over, I get 1/3, and so I have 1/3. Now I can multiply. 1/5 times 1/3. I'm so good at this. I know that this is 1/15. This also makes sense to me because saying I have 1/5 of a pizza and I have to share it with 3 people, so I'm cutting it into 3 pieces, the same as cutting it into thirds and taking 1/3 of 1/5. And when we hear that 1/3 of 1/5, that signals to us that we are multiplying. All right, let's take a look at a final. This is a slightly more advanced example. To be honest, you won't see a problem like this until 6th grade, but keep in mind, you guys now have 7 more days of school before you are 6th graders, most of you, hopefully. And so a great opportunity to look at this now. So in our last example, we have 2/3 divided by 3/8. It's the same process. We're going to keep, change, flip. I'm going to keep my first number the same. 2/3 stays exactly the same. In every single example, I kept my first number the same. 4, kept it as 4. 1/5, kept it as 1/5. 2/3, kept it as 2/3. I don't just start flipping things over just because they're fractions. I have to first keep the number the same. Then I changed my division into multiplication. And finally, I flipped. I flipped 3/8 over, so it was on its head. And once I flip it and get the inverse, 3/8 becomes 8/3. Now I can multiply. I know how to solve 2/3 times 8/3. That's something that graders do know how to do. I multiplied my numerators, I multiplied my denominators, and then I just reduced it. So I wasn't left with 16/9, I was left with 1 7/9. This will be an anchor chart located in your Google Classroom, so use it. But if you get stuck, draw a model. This is just another way of doing it. Some of us were already starting to see this pattern in this idea of keep, change, flip. All right, so let's put it into practice. You have your scrap paper out and ready to go. If you are stuck on any of these, go back and draw a model. But let's challenge ourselves to see if we can do it using our keep, change, flip. I'm just going to write myself a note at the top of my paper. Of course, you'll have your anchor chart to use as you are doing your independent practice. I know the first number, I just keep it, it stays the same. Then I change my division to multiplication. Draw myself a little note that my division is going to turn into multiplication. And then I flip. So let's say I had 5, that would have to become 1/5. I just flip my fraction on its head. If I need to write it as 5/1 to help me remember, my denominator became my numerator and my numerator became my denominator. That's what we mean when we say flip or taking the inverse. All right, I wrote my little note at the top of my paper. I would recommend you write yours as well, and let's dive in and solve. Number 1, go ahead and copy it down the way it's written, 4 divided by 1/3. I want to challenge you to try using keep, change, flip. Then we'll draw a model to prove it, but let's see if we can get this to work. First thing I do is I keep, okay? I'm gonna keep my first number the same. It does not matter if it's a fraction or a whole number, I have to keep it the same. The next thing I do is I change. I change my division into multiplication. And the last thing I do is I flip. I flip my fraction over on its head to be the inverse. 1/3 becomes 3/1 or just 3. And now I can solve. I can double check with a quick model. I'm going to draw out my 4 that I'm starting with. My original problem was 4 divided by 1/3. If I split each of these pieces, each of these wholes into 1/3, and then if I were to count them all up, I know another way of counting these would just be 4 times 3. So this makes sense. I understand why this works. 4 times 3 is 12. If you got 12, go ahead and give yourself a check. All right, let's try number 2. Go ahead and copy it down the way it's written. 1/6 divided by 5. All right, this is where most scholars tend to get stuck. And you suddenly think, oh, I want to flip my fraction and make it into 6. Do not get tricked. Remember, in our model, this would be like starting with a piece that's only 1/6, and we have to share that with 5 people. So I know that my final answer is going to be getting smaller. If I want to use my keep, change, flip, I need to keep my whole number, keep my first number. I know I always start with keep, so I'm going to keep my first number. Don't even think about turning that into its inverse. Keep, change. Go ahead and change your symbol. And now we can flip. We only flip that second number. So keep, change, flip. Go ahead and flip your 5. And now I know how to multiply. Go ahead and solve. And of course, we got to an answer of 1/30. Let's draw a model just to prove it. If I was starting with 1/6, like I only have this amount right here, and now I have to divide that by 5 people. So I need to divide this. And this amount right here is in fact 1/30. So it checks out. My answer is 1/30, which makes sense because splitting 1/6 of something with 5 people is the same as taking 1/5 of the 6th. 1/5 of 1/6 is just multiplication. All right, I want you to try 3 and 4 on your own, and then we'll check in. Remember, you're going to try keep, change, flip. Draw a model if you get stuck, but I want you to try our strategy of keep, change, flip. let's check in. I drew a model just to prove it. I bet you didn't even need to draw a model. All right, for our first question, 2/5 divided by 4. I know that nobody got tricked. We all remember that it goes keep, change, flip. Keep, change, flip. So nobody tried to flip their first fraction and said we kept it exactly the same. We're still starting with 2/5. Then we changed our division into multiplication, and then we flipped that 4 to show the inverse of 1/4. Once we have 2/5 times 1/4, it makes it so easy breezy mac and cheesy for us to multiply. We multiply the numerators, then we multiply the denominators, giving us an answer of 2/20. You also could have said 1/10. In my model to prove it, I first showed my 2/5. I know that amount doesn't change. Then I divided it by 4, the same as taking 1/4 of 2/5. So I see that where that multiplication is coming from. And I was, in fact, I did in fact get an answer of 2/20. Number 4, we're starting with 5 divided by 1/5. Well, I remember my keep, change, flip. I kept my very first number the same. I changed my division into a multiplication, and I flipped my 1/5 over to the inverse, which gave me 5. Made it really easy for me to calculate. 5 times 5 is 25. I can see that in my model right here because I drew out 5 holes, split them each, so the pieces were each 1/5. And that gave me a total of 25 pieces. In order to count that, I would actually just count by 5, 5, 10, 15, 20, 25, which is the same as multiplying 5 times 5. Pretty cool stuff. Let's take a look at how this might look if it were word problems. All right. We're going to try one together, then you have 2 to try on your own as we think about these word problems. If you get stuck, draw it out. There is nothing wrong with drawing a model. But you can also start to think about, okay, how could I solve this even without a model? Let's take a look at question 1. If there are 2 yards of copper wire, how many 1/16 of a yard pieces can be cut? I'm going to first just visualize what's going on in this story. I know there's 2 yards of wire, and we want to know how many 1/16 of a yard pieces can be cut. So it's like I'm taking each yard and cutting it into 16 pieces so that each piece is 1/16. So if I have 2 yards and I'm looking for how many pieces and they're 1/16, I know I can fit a lot of pieces. So I'm definitely looking for an answer bigger than 2. So I could draw this out. I could draw my 2 yards of copper wire and cut them into 16ths, but I think I can also do this by writing an equation and using my keep, change, flip. So I'm starting with 2 yards of copper wire, and I'm dividing them into pieces that are 1/16 each. Maybe 1/16 of a yard pieces, which now I can solve using my keep, change, flip. Go ahead and solve using your keep, change, flip. I'm just going to draw a model just to prove it. All right, what did you get when you wrote your new equivalent expression? Keep, change, flip. And of course, we know 16 times 2 is just 32. So 2 divided by 1/16 is also 32. This makes sense because if I had 2 yards of wire and I'm cutting it so that each piece, here's one piece, is just 1/16 of a yard, that's teeny tiny. I can fit 32 of those in there. I could count them by ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up through 32. I don't need to because I know I can just solve that by doing 2 times 16 is 32. All right, you're going to try number 2 and number 3 on your own. If you are stuck or unsure what to do, draw a model. I would 1,000,000 times rather you draw a model and get to the correct answer. But if you're starting to see some of these patterns and you want to try using the standard algorithm, be my guest. Go ahead and solve number 2. And then number 3. Take 10 more seconds. All right, let's check in and see what we got. All right, for question number 2. If Mr. Herrera has 4 cups of raisins that he's going to be serving his students, and he's putting those into 1/9 of a cup serving, so we want to know how many servings he can make. I know that's the same as 4 divided by 1/9, which we know is the same as 4 times 9. We could have drawn it out. Here's his 4 cups of raisins. Each cup or each serving is 1/9. That means each cup has 9 servings. So we could have counted them up by 9s, but we also can solve that as 4 times 9 is 36. If you got 36, go ahead and give yourself a cha-ching. And now let's take a look at question number 3. Question number 3 was telling us, so as you know, there's a shortage on a lot of items right now. And so I went to the store to buy some dog food for Watson, and they were all out. So they said they'll get some more on Friday. So I only have 1/3 of a bag left, and I have to make it last until Friday. I'm going to feed him the same amount over the next 4 days, and I want to know what fraction of the bag he can eat. He obviously can't eat the 1/3 of a bag today, or he won't have any food tomorrow, Thursday, or Friday. So it's got to be even smaller than 1/3. I know this is asking me to do 1/3. Here's the dog food that we have left, divided by 4 days. He's going to eat that 1/3 of a bag of dog food over 4 days. Now I can use my keep, change, flip to rewrite it as 1/3 times 1/4, which would get me to 1/12 of the whole bag. I can prove that with my model. Here is the dog food we have left, the 1/3 of the bag. I have to split that over 4 days. So this is what he's going to eat today, Wednesday, Thursday, and Friday. Each day he can have 1/12 of the bag. All right. Today we did a lot of work with dividing by a fraction. In order to divide by a fraction, it turns out we were actually multiplying by some fractions as well. Today, you will get lots of practice, both with just number sentences on their own and some word problems as well. If you need to draw a model, that's totally fine. There's nothing wrong with drawing it out with a model. If you want to try your keep, change, flip, keeping that first number the same, changing the symbol from division to multiplication, and then flipping your second number, whether it's a whole number or a fraction, to be an inverse, go ahead. You only have 4 problems today, really looking to see lots of phenomenal scores. I did want to close out by showing us our Vista virtual points, since I did not get to do that in the beginning. And then I also wanted to let you know that tomorrow you have a quiz, and then additionally, there's going to be just a very exciting announcement. So tomorrow you'll actually have 2 videos. One will be short and just a couple review problems before you start your quiz. And then the second one has nothing to do with math at all. It's just a really exciting announcement. So I would love for you to also watch that video as well. If you miss that video, you're going to miss the exciting announcement and you won't know the exciting news. So you will have 2 videos tomorrow, but they are going to be short. Really excited to share this exciting announcement with you. All right, let's take a quick look at your Vista virtual points, starting with Hadley. All right, so, and these are just from early this morning, so this does not include things like scholars who came to office hour or reteach this morning, scholars who came to social lunch today, already have a very strong top 5 with Corday, Philip, and Naira, Tanvi, and Manuel. You can see who is in the top 10. Excited to have lunch bunch with some scholars today who won that last week. I know some of you have earned a homework pass for today as well. So see if you can find your name to see where you're falling with your points. Congratulations, scholars at Hadley. And a quick look over at Maryvale. It's like Madeline in a strong lead. I know some Maryvale scholars earned a homework pass for today. Maryvale, you have some scholars still with 0 points, so make sure you're getting all of your assignments completed, showing the academic excellence. Come to office hours this afternoon with any questions. And remember, quiz tomorrow, and also exciting announcement video tomorrow as well. Don't miss it. All right, see you guys tomorrow.